Hi everyone, Dex here from RedStack, and thanks for joining us for today's webinar, BIM for Structural Engineering. So we will have Tomislav and TechNexus presenting for us. So just a quick introduction about RedStack. So we're a leading provider of design technology and services to engineering and architecture professionals. With over 20 years of local experience, we provide the expertise, training and support to help companies realize the full potential of the design technology. The RedStack mission is to deliver industry-leading services to the engineering, construction, and architecture communities. We work with clients and companies of any size nationally and abroad. Over to you, Tom.
Thank you. Thanks for everyone for joining me on today's call, and I thought I'd give a little bit of a background on myself first. My name is Tomislav Golubovic. I've been working in the industry for over 20 years now. Previous to becoming a contractor, I was at Autodesk for 8 years as a pre-sales tech specialist. So if you're on the call and have dealt with Autodesk in the past, you've probably come across me either in person or through a webinar or through other means, either online or at events. Previous to Autodesk, I was at various companies, Wally Parsons, GHD, Oricon, Boeing, to name a few, and I've covered, pretty much anything from basic vanilla AutoCAD right through to civil structural, piping, telco, even a little bit of medical work as well. So I think I do have a lot of experience and a lot of sort of varied fields that gives me the ability to talk about a whole bunch of different workflows and best practices between all of those products and fields and industries as well. So basically today, in regards to sort of the structural side of things, we're going to look at 4 products. And this isn't, what you see on the screen isn't necessarily the order we're going to cover them in, but we're going to look at Robot Structural Analysis, Dynamo Studio, Autodesk Revit and Advanced Steel as sort of one ecosystem and workflows for the structural disciplines. So with Dynamo is a tool that is included in the AEC collections, and there is a Dynamo kind of a studio app that's included inside Revit, but there's also a Dynamo Player. Now you can see on the screen there, it says that Dynamo is a visual programming language. So basically what you have there on the screen, so that number 2 is taken as an X. And then the number 6, we could drag that to the Y, and you see in the middle of the screen there, it's a maths operator. So it would be 2 plus 6. It gives us the 8th variable at the end. So it can be a whole bunch of different things. It can be it can take a Revit family and do something with it. It can be numbers and converting them to points or coordinates. But it's really one of those tools where if you're doing repetitive work, instead of having to remodel something in Revit or even Advanced Steel, so we can use Dynamo and Advanced Steel as well, it just means that we can sort of have one script, so a Dynamo script that the users can play the script and just enter the values as they need to build up whatever it might be in the project. So, if you're doing something like a portal frame, if you've been following my LinkedIn tutorials or even my YouTube videos, I do talk about using Dynamo to build up a portal frame inside Advanced Steel, which we could adapt for Revit as well. But basically, you can use numerical inputs to adjust the length of the warehouse or the portal frame, plus the wall height, plus the roof height, and whatever else that is adjustable, and then the software will automatically go through and create the models for you. Ultimately, as well, we do the Dynamo script to help us build the models inside Revit. So you can see there, this is the model that we'll have a look at later. So I've got a pipe rack there just made up of steel elements plus some connections. And then what we really want to do is send that to Robot. So we can send the model out to Robot to do some analysis on it, and we can look at those loads and whatever else we need to inside Robot, and then we can send that back to Revit if we need to. We can also import from Advanced Steel and even send it back as well. So, there is a true I don't know if we could say a circular workflow, but there is, you know, back and forth between at least 3 packages here that we don't have to keep, you know, dumbing down for any reason or doing any remodeling or redrafting as well. And then towards the end of this webinar, we're going to look at having that model inside Advanced Steel and then ultimately creating assembly drawings, single part drawings, and DXF files and NC files to send out to the cutting machines as well. So this is where we start getting into the finer level of detail as well. And then ultimately having, you know, a true 3D model, a BIM model as well. So we can have this model in Advanced Steel, we can have this model in Revit, and then that way, you know, you can satisfy the client's requirements for basically pretty much anything that they need on the project. So enough of PowerPoint, we're going to jump straight into a live demo of this. So inside Revit, and I'll just shut this down for the second. So inside Revit under the Manage tab, so I'm on 2019.2, but on the far right, there's a button here called Dynamo, which gives us access to the Dynamo platform, but there's also the Dynamo Player. So the Dynamo Player just gives the end users the ability to play the scripts and not necessarily, you know, the end users don't have to be smart users in regards to sort of writing code or scripts. It's really just them to play the scripts, and ultimately you would have someone in the company who is the dedicated Dynamo scripter, and they would write the scripts. So the Dynamo Player is for the front end sort of people, but the person writing the script would select the Dynamo button here, and Dynamo is presented as kind of another app or platform within Revit. So there is, you know, new nodes and opening and recent sort of scripts is there. There's a forum, there's a Dynamo website. There's a whole bunch of sort of reference areas here. So the primer, the video tutorials, and any dictionary. So again, there is a lot of information there. And as well, there's also some samples down here as well. So we do have, you know, like this one here. So geometry solids. So when it does run, so you can see down the bottom here, it's got it as run as automatic. So this is what the Dynamo software will be producing. So if I click on some of these values here, so I can, let's look at some of the values that I might change. So if we change this to something extreme like 150, then you can see the model behind me has changed there as well. So the numerical inputs might be something to do with, you know, the length of a bridge, the width of a bridge, the length of a building. Again, it could be anything that, you know, is quite repetitive that you don't want to keep, excuse me, you know, having to remodel every time. Now, as well, if I jump into Revit, we can see that I've got that same results of the model inside my Revit model. So again, I could use these points as either connection points for beams, or I could have these lines as, again, a representation of something that I need to keep doing over and over again. So I'll just close this one down, and I will open up, let's look at one of the other ones. So structural framing. Okay, so I think this one should be fine. So again, here you can see that it does run with sample files. I don't have anything in this model, so I can't select anything, but ultimately this is used to build up a structural frame of sorts, and you've got even integer sliders. So this could be just a slider bar for people. You know, as an example, it could be the number of floors, it could be the number of walls, it could be the number of sides on a polygon or something like that. And you can see that all of these values do carry over. So this integer slider becomes part of the code block here, which becomes part of the curve point, which becomes part of the lines. And again, this is why it's a very visual kind of program. And then that way you can go through and slowly build up structural frames, and then ultimately build up your Revit model, which can contain various Revit elements as well. So not only from building up the models, but there is also, so there's some values in here, so calculate room occupancy as well. So if, you know, the report information about the selected room and its occupancy load based on the allowable number of occupants per room area. So there is a lot more to just, you know, just the modeling. You can use Dynamo to renumber rooms if you want to. You can use Dynamo, like I said, you know, it has here to work out the occupancy load. So again, it's just something that you might spend a couple hours working on, but ultimately you would use these Dynamo scripts to help you through the course of the life of the project and future projects, just to click a button and to get a lot of this to be automated for you. So then that way you don't have to spend you know, precious time just working out things that something like Dynamo as a script could do for you. Okay, so that's Dynamo. So that's sort of at the beginning of the project where you're going to be doing repetitive work, or even on the life of the project where you are doing repetitive work. But as a modeling sort of idea, so let's say we can sort of pretend that Dynamo has built up this steel model for us. So this is, these are all Australian sections in here. So I do have 200 UB 18.2 in here, and you can see under the steel, so under the structure tab inside Revit, there is a connection dialog box. So I can go through and put all of these connections in here. I can even go through and modify the parameters to suit what I need for that joint there as well. So I can see if I go to plates and bolts and go to horizontal bolts, if I want to change that from 3 to 4, I can just type in there 4, and you can see Revit goes through and puts in the 4 bolts as well. So this has been out for a little bit, but you know, again, over the course of the years with Revit 2019 and Revit 2020, these always do get updated as well. And then, you know, we do have all of that information in there, and it's all part of what's called a steel connection inside Revit. So just to show you how we can do that is I can go through and select 2 of these beams, and then if I go back to the structure and say, give me a connection there, it places a generic connection, but then I can go through and say, make that a shear point. There you go, it's done it the wrong way. So let's pick these 2 again. Go connection. Okay, it's bugging out for me, but we can see that that connection is in there, even though it is wrong for this demonstration, but we can see that we've got 3 bolts in there. If I want to modify and adjust it, then I can go through and adjust these values in here. So number of horizontal bolts, vertical bolts, the actual bolts themselves. So I can see what kind they are. So if I want to do AES 1111, so then I can go through and say that they're 16 mil bolts. And I've also got options for nut and washers and nut and 2 washers. And you can see it all makes those changes in there in the model. And then once I've gone through and populated all of those, so regardless, I can go through and grab sections in here as well. I can have them on sheets. So all of my views are automatically populated inside Revit. So this is just a section through level 1, level 2. I've also got an isometric view, so all of my views are always updated. So you can see here, I haven't had to go through and update the views. All of these views are automatically populated, and I can also cut in some sectional views here as well and dimension and annotate them as well. Okay, so once in the workflow, in the scheme of things, at some point you'll need to do some analysis on this as well. So I'm just going to close these down. And let's say we're at a point where we're happy with this model as well. So I do have Robot 2019 installed. So under the Analyze tab, I can go through and send all of this out to Robot. So I can send the model out to Robot and just go OK. And it'll do its thing, give it a few seconds. I'll say no to the report. But then when I do jump into Robot, you can see here in plan view, I've got all of my columns, I've got all the grids, I've got all of my members in here, and then I can go through and start loading in any load types, do some analysis, look at the results, so diagrams and maps and any displacements or deflections as well. And then that way, again, I can use, you can see there that I didn't have to go through and redraw or redraft anything. I can just grab that model straight away from Revit, and then it does appear inside Robot directly. So there's also under the add-ins with the integration, I can send it back to Revit, to Advanced Steel, or even Inventor frame analysis. So for any of the users on this webinar, if you are using Inventor, you can use it with Robot as well for some of the analysis tools that are available to you. So once you do get it all set up and happy with what you want, we can send that information back here into Revit as well. So following on with the workflow, once you're happy here, Revit does not do shop detailing as such as it would properly in Advanced Steel. So you can see here, even though we can create views and dimension the plates and the bolts and everything else, this isn't really what a shop detailer would use in their workflow for the files. So basically what we can do is use the Manage tab over here, sorry, the Add-ins tab, and we can export this whole model out into an SMLX file. And inside Advanced Steel, I can import. So under the Export Import tab, I can import, export, or synchronize a Revit file. So I can import that file. And you can see I don't have to do anything. It all comes in, all of my connections come in. Okay, so you can see here that 4-bolt connection, and then inside Advanced Steel, I can look at the joint properties of that and even make changes to that again. So if I want to go extreme, I can come in here and put 6 bolts, and you can see it's put 6 bolts in there as well. Okay, I'm just going to save this. And I can also export those changes out. Okay, and then I can also, as sort of a two-lane kind of thing, we can model in Advanced Steel and we can model inside Revit. I can synchronize those changes. So Advanced Steel tells me that there's been some changes made. I can just say apply all the actions. And we'll give that a few more seconds. And then ultimately the 6-bolt connection that I had here in Advanced Steel, and I'll just let that finish, will be inside the Revit model as well. So if you are dealing with companies who are using Revit for their modeling and you are working with a steel detailer as well, if they decide that the model needs to change and you need an update, then we can send those changes back to Revit. So when we do look at the workflows of the two products, you could literally have these products working side by side to have a Revit model and an Advanced Steel model. So rather than just let that wait, we'll just continue. So as part of the workflow for all of this is the whole idea of using Advanced Steel is to get production drawings for a steel detailer, for someone out in the factory. They need to know how to cut these beams and plates. They need to know how many, the surface area. They need to know the weight and anything else that they need to calculate it by. So in Advanced Steel, we can go through and do a numbering procedure on these. And the reason for that is that we need to see, if I look at the properties of that, I can see that it's a single part number 1001 and it's part of assembly number 2. So because it is part of an assembly, I can see what it's part of. But as a better detail, like if I click this one and as a mark to see what it is, so you can see the elements in red are telling me that these elements in red are all welded together in the shop, and essentially this is what the assembly is going to look like when it goes out to the fabricator. as an assembly drawing. And then also as well as a single part, they will get this beam and these plates all as a separate single part drawing. So to do that inside Advanced Steel, we have what's called drawing processes. So I can say, give me a list of all of the drawings, so of all the MP parts. And what that does, just in the background, it'll go through and create the drawings. And it'll put them, by default, these are just Advanced Steel title blocks, but you can obviously customize the title blocks to suit. And then once that's done, we'll have a whole bunch of drawings. And by default, with the numbering, if it finds columns and beams and any other assemblies or single parts that are the same, it will number them the same. So you can see this beam here. So if this one, the joints and the lengths and the trim and the cope and everything are all the same, it'll tell me that there's 4 of these because they're all exactly the same. So that way, your fabricator, when he does cut the beams, he doesn't need to cut 4 different ones. He can cut one beam profile exactly the same 4 times, and then that way he's not wasting time and money just doing various elements there as well. So I'm just going to let that finish. So what this is doing is where this file is living, it makes a subfolder called drawing 1, and inside that it's making a whole bunch of drawings and calling them, the directory is the same name as the model, and then inside that it's numbering, it's got the parts that are numbered, and then it puts it on various drawings. And you can also control that as well, so you can have the drawings that are numbered the same as the part themselves, or you can say that you want a particular range of numbers for assemblies, a particular range of numbers for single parts, and a range of numbers for GAs as well. Okay, so hopefully it shouldn't be too much longer. So just to show you on my desktop, so you can see drawing 1, details, and you can see there that it's making all of these assembly drawings. Okay, so now if I want to see that assembly drawing, I can see, so just assume because this is the standard one, we can go through and tidy up, but you can see it's telling me that whole column there is 3 meters long. There's a 10mm plate on it. We've got the locations for these fin plates or the shear plates there as well. We've got the part numbers, we've got the welds, any other sections, base plates, all of that kind of stuff as well. And then even down here, you can see that assembly number 25 is made up of 8 parts. So 1 UC, 1 204 by 10 plate, and 6 140 by 10 plates. Length, grade, all of this is customizable. The total weight per the individual elements, and then obviously the overall weight of that assembly there as well. So just to make things a bit quicker, what I'm going to do is just put a window around these and say, give me all of those single parts on A3 sheets. So if I jump back over here, you can see that it's populating my S range of drawings. So then that way we can see the single parts. So I can do the same for this plate. I can say, show me the part detail, and then there it is. So automatically, I don't need to do anything. I can just click a button and let the software go through. Also as well, the document management system in here, if I make a change to this plate, the document manager will tell me that it needs to be updated. And then from there, as an end user, you can decide whether or not you want that to be up-revved, which it will up the revision. So it'll go from a Rev A to a Rev B, and it will also put a revision cloud in there. So if I wanted to do something like that, I can go through and say, give me horizontal, so I can put 4 bolts in there. And then if I go to my document manager, you can see that that update has affected 3 drawings. So if I do update the revision, so I can say issued for construction, TG, and I'll just spell that right, go OK. Okay, so now if I look at the single part drawing for this, it's told me, it's basically put a revision cloud around everything saying that those holes have changed, and there's the revision there as well. Okay, and like I said, ultimately, if you have your steel detailers working inside Advanced Steel, then we can synchronize with the Revit model. And if I jump back into Revit, you can see that those bolt changes have come through. So now the people using Revit, so if you're working with architectural and services, so if you've got a cable tray or duct hanging off this steel structure, they can see that there's been changes in here. So you want to find all of these changes before obviously anything happens out on site. So it's not part of today's discussion, but you'd use something like Navisworks to bring all of those models together, and then that way we can produce a federated model using Navisworks to do clash and timelining on. Okay, so I'll just go back to our overall. So we did a little bit of sort of early stage scripting and programming in Dynamo Studio. We did some of the design inside Revit, so we can place other members and structural connections in there. We can do the analysis inside Robot Structural Analysis. We can send those changes back, and we can also work with Revit and Advanced Steel to get our fabrication drawings. So someone in a workshop somewhere can cut steel and cut holes in it, and then obviously send it all out to site and put it all together like a big Lego piece. So that covers my demonstration side of things, and I know we're doing a Q&A. If anyone has any questions, please write them down, and I think Dexter's going to relay some of them.
Yeah, so everyone, if you have any questions, you can write them down on the questions panel. So we'll just wait for a couple of minutes. So we have a question here from Nick Lancaster. It should be noted that if you are using existing framing families, you will need to rebuild all your content with 2019 families. So it includes the section key properties.
I do recall something about that with the custom parts. I think there was a bug or an issue in either around 17 or 18, but I'm 99% sure that they said with the structural connections in 19, it didn't have to worry about that anymore. The only thing I can say for that is probably if you want, get in touch with the RedStack guys and we might do a one-on-one to delve into that a little bit further. But like I said, I do recall there was a bug around the 17-18 time, and I'm pretty sure that was resolved in 19 with custom profiles, if that's where you're getting it.
Yep, and yes, Alex, we will have a recorded webinar and it will be uploaded on YouTube.
And I do say to everyone, you know, again, it's if you need any more information or you want to do a bit more of a one-on-one, get in touch with the guys at RedStack or you know, Dexter or anyone else, whoever you deal with at RedStack, and you can ask for me, and then we can have a bit more of a chat. I am based in Melbourne, so obviously happy to do in person, or if I need to, I can do it online if you're not in Melbourne.
Yep, and we have a question from Eddie. So is there any data loss when importing models between Revit and Advanced Steel?
No. So structural elements will come over, plates, bolts. You can see all of the connections come through. The concrete from memory does come through, but it doesn't like the sinking side of things. So I'd probably look at a different workflow, but you know, you just saw there that because I do have this listed as a 200 UB inside Revit, if I jump to Advanced Steel, so this does come through as a 200 UB as well. Now there is, I probably won't delve into it too much, but under the tables, so there is one called mapping. I think it's called GTC mapping. There is a database entry inside here that talks about if you're going from Revit to Advanced Steel or Plant 3D to Advanced Steel. So most of those, you can see the members that I brought in, I didn't need to do any mapping for. If it does import from Revit or Plant 3D, and it can't find the profile, it will pop up a dialog box and ask you to map the element between one to the other. And that also happens with other file formats. So things like SDNF and IFC, let's say in Tekla, for example, and I don't know this exactly, like in Tekla, it might be called UC 150, and Advanced Steel is called 150 UC. So when it does come up with those issues, it will prompt you for a dialog box.
Yep, and we have a question from Alex. Is there a plan on Autodesk to further develop Advanced Steel, or will it be included on Revit in future versions?
I have absolutely no idea. As far as I know, Advanced Steel will always be the detailing tool. When Advanced Steel was purchased by Autodesk from Greytech about 4 odd years ago, they did purchase Advanced Steel and Advanced Concrete as kind of a package deal, I guess, if you want to call it. But they have implemented a lot of the Advanced Concrete elements, like all of this rebar and Rio from the Advanced Concrete side into Revit. But as far as I know and am aware, Advanced Steel will always be the tool to do the detailing, and Revit, you know, there's nothing in here that says give me single part drawings from here. So yeah, like I said, as far as I know, Advanced Steel will always be around.
Yep, so we'll just wait for a couple more minutes.
Also, one of the other things, I guess, while we're waiting for a question is, if you are looking at Advanced Steel, one of the other things I do with RedStack is Advanced Steel setup and you know, things like title blocks, you know, the look and feel. So all of these drawing processes, you can make them look like, you know, your own standard as well. So we do that, and we also do training with Advanced Steel as well. And we can also talk about the ecosystem. So, you know, Advanced Steel plus Revit plus Robot. Again, just talk to the guys at Revit, and then ask for me to have a chat, and then we can take it further from there.
So any more questions, guys? So we're just about to wrap this up. So if you have any more questions, you can contact us at RedStack at solutions@redstack.com.au. Have a great weekend, everyone. Bye for now.
Thank you.